Welcome to the first of your geometry videos involving proofs. The proofs that you'll see in the video today will be based upon the definitions or the vocabulary words that we did in our notes packet on pages 3, 4, 5, and 6. All right, the word proof is a scary one to some geometry students, but put very simply, all a proof is a list of statements that we know to be true or correct, together with the reasons why we know those statements are true or correct. And there are many times in life where we want to focus on statements that are true or correct, and that's what a proof really does for us. Anytime that we're given a statement, such as the given in number 1, which says that G is the midpoint of line segment DE, the statement is always known to be a true statement. I'm going to, in each and every case, mark the givens in the diagram that I'm given. For instance, in number 1, if I know that point G is the midpoint of line segment DE, there's point G, I know that a midpoint will split or divide a line segment into two congruent segments. So because G is the midpoint of line segment DE, I know that line segments DG and GE also are congruent to each other. And that's kind of the direction or the gist with what we're going to go or where we're going to go in each proof. If we know one thing is true, what else do we know has to be true as well? So in a proof, I'm always going to start, or almost always going to start with my given statement. So G is the midpoint, and I'm going to abbreviate midpoint MP of line segment DE. I'm going to enclose that or inside a bubble or a cloud or a box. And then underneath the box or the bubble or the cloud, I'm going to write the statement that the reason why I know that statement to be true. So inside the bubble goes my true statement. Underneath the bubble goes the reason I know that's to be true. I know that that's a true statement because it's given to me to be a true statement. And then, by virtue of the fact that G is the midpoint of line segment DE, I also know that line segments DG and GE have to be congruent. I know that that has to be a true statement as well. And how did I know that? Well, a midpoint's job splits a line segment or divides a line segment, however you want to say, into two congruent segments. And there is my first little mini proof. I know, again, inside the box goes the statement that I know to be true. Underneath the cloud goes the reason why I know that's to be true. So if it's a true statement that G is the midpoint of segment DE, I can also conclude or deduce that line segments DG and GE are congruent. And the reason why I know they're congruent is because that's a midpoint's job. The midpoint's job is to split that segment into two congruent parts. So congratulations, you have just written your very first proof in geometry. Hopefully it wasn't terribly painful or harsh. Let's go try another one. Number 2 says line segment DE is perpendicular to line segment FG. Remember that this little upside down T symbol means the word perpendicular, and the word perpendicular means intersects at right angles. So if line segment DE is perpendicular to line segment FG, I know that there needs to be some right angles somewhere in my picture. So let's go take a look at our picture. That red line segment is line segment DE. It's perpendicular to line segment FG. Line segment FG I'm going to make blue. So I know now that where the blue one and the red one meet, I must have some right angles. That's what perpendicular means. Perpendicular means intersects to form right angles. So I know that this given statement is a true statement because I'm only ever going to be given true statements. They're the only kind that we want to talk about in geometry this year. So I'm going to go ahead and start out my proof by saying or stating that line segment DE is perpendicular to line segment FG. That's my statement that I know to be a true statement. And the reason that it's known to me to be a true statement is because it's given to me to be a true statement. And because those lines are perpendicular, what I know, or the conclusion that I can draw from that, is that I know that angle DGF and angle EGF have to be right angles. So the statement that I know to be a true statement is that those two angles are right angles. The reason that I know that that's a true statement is because perpendicular lines always form right angles. And there's my second little proof in geometry. If these two are perpendicular, it must be that those two are right angles. All right, let's shoot on to the next one. Number 3 says line segment DF is congruent to line segment EF. So I'm going to go ahead and mark those as congruent in my picture. And remember, the way in which we show that two line segments are congruent to each other is to mark them using the same number of slash marks. So DF is this little guy along the left side of the triangle. I'm going to mark him with a hash mark. EF is this little guy along the right side of the triangle. I'm going to mark him with a little hash mark. And what it means for two segments to be congruent to each other is that they have to have equal length or be equal in measure. So therefore, if two line segments are congruent to each other, I know that their lengths or their measurements have to be congruent or equal as well. So I'm going to go ahead and start off with my true statement. The true statement that's given to me is that line segment DF and line segment EF are congruent. I know that's a true statement because it's given to me to be a true statement. And if I know that those two are congruent to each other, then it must follow that their lengths or their measures are equal. The way I'm going to demonstrate or show a length or a measure is to say the distance from point D to F is equal to that of the distance from point E to F. So whereas the segments were congruent, the distances between the points are equal. And how do I know that? Well, congruent line segments always have equal measures. That's what it means for two line segments to be congruent. Or I could have said equal length if you prefer that. All right, hopefully you're starting to get the gist of this and it's starting to feel a little bit more comfortable. If not, we've got lots of examples to practice with. I'm going to go ahead and flip up to the top of the next page. Number 4 says line segment QP bisects angle RQT. So the first thing I'm going to do is go find angle RQT in my picture. Angle RQT is that guy right there. Segment QP is that green line segment right there. And I know that bisects, that word bisects, means divide into two equal parts. So what that statement is saying is that my green line segment divides the red angle into two equal parts. The way that I'm going to show them to be equal in my picture is to draw one blue arc in each one. And if that line segment bisects that angle, I know that I'm going to end up with two equal angles. And the two equal angles in my picture are going to be angle RQP and angle TQP. So I'm going to go ahead and start out my proof by writing that true given statement, segment QP bisects angle RQT. And again, you can use a rectangle. I like to use the bubble, or some kids say the cloud. I know that's a true statement because it's given to me to be a true statement. And if this guy is a true statement, then what I also know has to be a true statement is that angle RQP and angle TQP have to be congruent to each other. So there's my true statement. Why did I know that? Well, that word bisects means split into two equal parts. So I'm going to say an angle bisector forms or makes two congruent angles. So again, this is my true statement. Written in green is how I know that statement is a true statement. All right, moving on to number 5. Number 5 says line segment AB intersects line segment CD at point E. And if I look at the picture, I can see very clearly that these two definitely do intersect. That purple is line segment AB. The blue one is line segment CD. I really don't know anything about the way they intersect. I don't know if they intersect at right angles, if they intersect in such a way that they bisect each other. That's really not given to me at all from what the statement is presented or how the statement is presented in the given. What I do know is that anytime two angles or two lines intersect, I know that the vertical angles that are formed have to be congruent to each other. So I do know that angles AEC and DEB have to be congruent. I'm going to do something here that's going to be kind of a little shortcut so that I can avoid using those angles formal names every time. And instead of naming them by using a long formal name, 3 letters, I'm going to use a nickname. I'm going to call angle AEC angle 1, and I'm going to call angle DEB angle 2. All right, so when it goes down or push comes to shove and it comes time to write my proof, I'm going to go ahead and start out by saying that line segment AB intersects line segment CD at point E. I know that that's a true statement because it's given to me to be a true statement. And because those two lines intersect each other, I know that the vertical angles formed have to be congruent. So I know that angle 1 and angle 2 must be congruent to each other. And the reason for that, vertical angles are always congruent. All right, and then down at the bottom, number 6, the last one, says line segment PQ bisects line segment RS. So PQ is that red one. RS, I'm going to make purple. And here's where you have to be really super uber careful. That word bisects, we understand, means split into two equal parts. But you have to be careful about the one that is being split into two equal parts. The one that's being bisected, the one that's being chopped into two equal parts, is line segment RS. So that's the one that I made purple in my picture. That's the fellow that's going to have two equal parts. So I'm going to go ahead and mark his parts as equal. PQ is not being bisected necessarily. He might be split into two equal parts. He might not be. We really don't know from the information that is presented or given to us. So in going to write our proof, I'm going to go ahead and start out with that given statement. Line segment PQ bisects line segment RS. I know that's a true statement because it's given to me to be a true statement. And because of the whole bisecting thing, I can deduce, or I know, that line segment RT and line segment TS have to be congruent to each other. That's the job of a segment bisector. It goes around splitting segments into two equal parts. So why do I know that these two have to be congruent? Because the word bisect means to split into two equal parts. And I'm going to say two congruent parts. All right, at this point, if you're feeling fairly comfortable with the proofs, feel free to go ahead and turn the video off and call it a night. If you're feeling like you could still use some more support and some more help with the proofs, I'm going to go ahead and move on to the next page and do the last three. So this is a kind of as you need it. If you need it, you have it. If you don't have to do it. All right, number 7, up at the top of the next page, says that line segment PN and line segment KQ bisect each other. So what that means is that line segment PN will bisect line segment KQ, and at the same time, line segment KQ bisects line segment PN. So I'm going to go ahead and color code those in my picture. I'm going to make line segment PN red, and I'm going to make line segment KQ blue. What that statement means is that the red one will chop the blue one into 2 equal parts. So I'm going to go ahead and label that in my picture. In addition to that, not only is the red one chopping the blue one into 2 equal parts, but that blue one is also dividing the red one into 2 equal parts. And I wanted to label the pieces of the red one as equal to each other, but not necessarily equal to those that are formed on the blue line segment. So I'm going to mark my red pieces with 2 hash marks where I mark the blue pieces with only 1. So this one given actually gives me 2 new statements that I know are both true, which is kind of neat, kind of unique, kind of different. I'm going to go ahead and start out with that given. Line segment PN and line segment KQ, bisect each other. I know that's a true statement because it's given to us to be a true statement. So my reason there is given. And because those guys bisect each other, some other true statements I know that line segment KM is congruent to that of MQ. I also know that line segments PM and MN are congruent to each other. And as far as the reason that I know that's true, I'm going to say a line segments or a segments bisector splits it into 2 equal parts. Or 2 congruent segments. All right, moving onwards. Number 8 talks about right angles. I'm going to go label those right angles in my picture. So angle SML is this guy right there. Angle SMP is this guy right there. If those guys are right angles, I know that right angles are only formed when lines are perpendicular. So I know that SM must be perpendicular to MP. So because those guys are right angles, I know I've got some perpendicular lines going on in my picture, and that's what I'm going to talk about in my proof. So I'm going to go ahead and start with my true statement, or my statement that I know to be a true statement as a result of the givens. So I know that angles SML and angle SMP are right angles. I know that's a true statement because it's given to me to be a true statement.
Turner McKenzie, Sam LeBlanc, and Tom Oliak to the counseling office.
And because those guys are right angles, the conclusion that I can draw is that line segment SM and line segment LP must be perpendicular. And that's because right angles are formed by perpendicular lines. Or right angles are formed when lines are perpendicular. right, and that leaves us with just one more. Number 9 is kind of an interesting and intriguing question also. In the given, they tell us that B, P, and D are all collinear points. In other words, that this line that those lie on is a straight line. Ordinarily, we'll let you infer from the picture or the diagram that that is indeed a straight line. But what we know from that picture is that if those 3 are all collinear points and lie on a straight line, we know that this angle formed here inside the triangle and this angle formed here outside the triangle must be supplementary angles. And rather than, again, name them by their formal names, I'm going to take a little shortcut here and give them each a nickname I'm going to talk about in my proof, angles 1 and 2. So because that's a straight line, I know that angles 1 and 2 have to be supplementary angles. So I'm given that B, P, and D are all on one line segment. That's my true statement. I know it's true because it's given to me to be true. And if those are all on the same straight line, I know that angle 1 and angle 2 are supplementary. And this year we're going to abbreviate the word supplementary by using SUPP. And the reason, I know that they form a linear pair. So linear pairs of angles are always supplementary. Well, if you stuck it out this long, thank you, thank you, thank you from the depths of my heart. I appreciate you bearing with me. I hope that I made it worth your while and that I'm making these proofs start to make sense. As always, if you have questions, jot them down in the margins right now so that if you when you come back to class, you can make sure to remember to ask. We're going to do some practice proofwriting when you come to class, so if you're not feeling good and confident about it now, hopefully you will be sometime soon in the not too distant future.